Hello again. I just want to give you another quick update on the Pi3C modeler and some of the experiments I've been doing the past few days. And the first experiment you may have noticed is that it's changed color. I've added themes to the graphics user interface so that you can change it from pinks or raspberries or blues or greens, whatever sort of color you would like for the user interface. So I've been working on the graphics user interface in that way, and the other way I've been working on the GUI is also to speed it up. One of the problems we had last time, I was showing the extrude and the lathe tool on the Pi 400 because it was too slow to operate on the Pi Zero. So I'm just going to show you very quickly that we can now run very quickly on the Pi Zero using the line tool for extrude and for also the lathe as well. So let's just draw a quick letter. There's a P. Let's put the hole in the middle as well. It's just a lot easier now. Before, what was happening was the graphics user interface was actually too slow for the line rendering to also render at the same time. So I've now speeded that up. Let's just try and get a roundish circle on top of there for Pi, and then let's click the right mouse button. We have down here the extruded Pi. Let's move it over a little bit and let's see if we can draw an acorn over here using the lathe tool. So here is an acorn shape. There we have an acorn. So there we have the graphics user interface speeded up with line rendering and also the themes. There's a few more other things have gone underneath the hood, have been going on, like garbage collection and so on. So there's been quite a few improvements in a 3D modeler, but a lot of them you can't actually see. Now I'm going to show you one other experiment that I've been working on recently, and is something which every games programmer has probably challenged themselves with, and that is to make a Minecraft scene. And so I thought I would also use the traditional chunks and Perlin noise maps to create a Minecraft scene. So on the bottom left hand corner we've got a new icon here. It looks a sort of chunky icon, which I'm going to generate using Perlin noise and the chunks to actually generate a Minecraft map. Now, one of the reasons why I've tried this is to see how far, again, I can push the Pi Zero and see how complex a scene we can generate. And I have actually filled this scene with trees and lots of other sort of features which we'll have a look at now. Let's go to full screen. Okay, and we can start to just move around this scene and see how fast or how slow it is. Now you'll notice it is pretty slow because it is using 8x8 chunks. Each chunk has 16 by 16 by 256 voxels in it, and so it is quite slow. And one of the reasons why it is slow is because it's calling lots of draw calls. The Pi Zero does not like draw calls, so there's going to be, I'm going to probably have to reduce the number of chunks in the scene. But it shows you that we can do quite a complex scene with the Pi Zero. You'll also notice if we zoom down to, let's turn the grid off. If we zoom down to the blocks below, we've also added shadowing and a bit of biome, and we've got two types of trees. We've got birch and oak. And if we go all the way through down to the map, let's go underneath. We can actually see I've also added a cave system as well. Now the cave system isn't done the traditional way. Some of the people have used Perlin, what's known as Perlin worms, and all kinds of tricks and to actually generate caves. And I thought, well, the simplest way to do it is just to jam two noise maps together and that merge them together to get a sort of large caves. I've even tried stalactites, which aren't very effective at the moment, but just to give an idea of what can be done. And so we've got caves and we've got the landscape completely generated using Perlin noise, and also added trees. I'm also going to add other features like the grass and all that sort of thing. Now I'm just going to compare this with the speed on the Pi400. The Pi400 is going to be considerably faster, so let's switch over to that now. Okay, so I've now loaded this scene up onto the Pi400, and straight away you can see as I'm rotating round and as I'm moving, it's a lot faster than the Pi0. And that's down to the jaw calls and not so much the graphics processing unit. The graphics processor on the Pi400 is not that much more powerful than the Pi0, but it's just the number of draw calls, as I said earlier. So the Pi0 is going to, if it's going to be usable, playable game, it was going to have to only render less chunks, which means that flying up above in the sky like this, it won't look too bad on the Pi400, but it will suddenly look very small on the Pi0. So walking around on the ground with sort of mountainous terrain and lots of trees and detail on a Pi0 will sort of make you think that you're in a much larger map, whereas on a Pi400 we can actually fly around and get a better view. So that's how I'm going to have to try. I'll start experimenting and see if I can speed up the Pi0 rendering. But it's just to give you an idea really of how much faster the Pi400 is, and then it shows that it really is quite usable to make a good working Minecraft game. So there's a quick update of the Pi3C modeler, its updates, and one or two of the experiments I've been doing to the modeler itself. So anyway, I hope you enjoyed that episode, and again I'll report back with improvements on the blocks module and also improvements on the modeler. Thanks again for watching.